All right, so continuing on with our polynomial discussion, let's talk about end behavior. So before we get into that, though, let's talk about just general graphs. So polynomial graphs are always all polynomials are continuous over all real numbers, and they're smooth, which means so you can see here we have a couple examples of polynomial graphs. And by smooth, we just mean that there's no sharp edges. They're perfectly continuous, meaning, I guess, very basically, you could draw it without lifting up your pencil. And then they're smooth, meaning we don't come to a sharp corner like this. So there's no corners. Both of these points here would not happen in a polynomial graph, which helps us when we're sketching these, because you know that it's always going to it's going to have smooth curves, smooth transitions, all of that. The other thing that helps us is we can always identify what direction the graph is ultimately going to go in based on a couple of things. And so we'll see this in a minute. But the end behavior of a polynomial describes what happens as x becomes very large in the positive or negative direction. So basically, as x goes to infinity or as x goes to positive infinity. And polynomial graphs will always go either up to, so they're always going to go up without bound, or they're going to go up to positive infinity, or maybe they're going to go down to negative infinity. It's always going to do one or the other. So if you think about like an exponential function, which we hadn't really, well, we did talk about those a little bit, but if you just have an exponential function, it looks like this. And so in this part, it never goes, it goes to zero in this case. Does it go to negative infinity? It does go to positive infinity in that direction. But polynomials, when we look at the ends, they always go up to infinity or down to negative infinity, one or the other. So how do we decide that? So the way you figure that out is you just look at the leading coefficient. And so in this example that we're about to do, negative 2x to the fourth is the leading term, I should say, because it's not just, it's the coefficient plus the exponent. So odd degree, so meaning that highest exponent is odd. If it's odd and the leading coefficient is positive, so for instance, like y equals x cubed, that would be an example here. Not this exact graph, but an example where, so we're not worried about the middle, in other words. But when we have an odd degree and a leading coefficient that's positive, the graph looks like this. And so as x goes to positive infinity, y is also going to positive infinity because it's going up. It's going up on the right side. And in this case, we're going down on the left side. So as x goes to negative infinity, y is also going to negative infinity. Then if we have a leading coefficient that is negative, of course, it flips it upside down. And now when x goes to negative infinity, the graph is going up. And so as x goes to negative infinity, y goes to positive infinity. And then on the right, it is going down. So as x goes to positive infinity, y goes to negative infinity. So that's with the odd degrees. With the even degrees, if the leading coefficient is positive, so this, well, back to this, and this looked like y equals negative x cubed. This one, we could use y equals x squared. Sorry, x squared. And in this case, both sides are going up to infinity. So as x goes to negative infinity or as x goes to positive infinity, both sides are going to infinity in on the y part. And then when the leading coefficient is negative, so like negative x squared, then it's going upside down, and they're both going to negative infinity. So this is really all you need to know. It doesn't matter what comes after this. So if you could have an x to the seventh, and it would still do the same thing. But you could also have x to the seventh and then have 6 terms after that, or seven terms if you wanted. But it doesn't matter what comes after that. As long as 7 is the highest exponent and the leading coefficient is positive, it's going to look like this on the ends. Now, what happens in the middle is anybody's guess. But as far as end behavior goes, that's all you need to look at. So if we look at this one, negative 2x to the fourth is our leading term. So this is an even degree. So the degree is 4. And negative lead coefficient, which is -2. And so we are going to be on this one. And so again, x to the 4th doesn't really matter what happens in the middle. But we do know that it's going to look like this. And so we'll kind of, it could look something like that, but we also know that at some point it's going to go back down and it's going to continue going down forever. So in this case, as x goes to infinity, y goes to negative infinity because it's going down. As x goes to negative infinity, y is also going to negative infinity because it's also going down. So that's really all you need to do. We're not worried. So notice we didn't talk anything about these 3 terms. These have no effect on the end behavior. They only affect what's going on in the middle. So for end behavior, just pay attention to the even or the degree and the leading coefficient, and that is all you need to know. All right, so we'll pick up on zeros on the next video.